Again, to solve an absolute value inequality, it's just like an absolute value equation. You want to get x by itself, and whenever we're dealing with an absolute value, we want to consider two possibilities. You want to solve it once in case the absolute value is the positive answer. Then you want to solve it once in case the absolute value, oops, sorry, dropped my 10. In case the absolute value is negative. But anytime we're changing, using a negative, anytime anything changes with a negative, we flip the sign. Just like I did here. The sign flipped. So now that we flipped our signs, we can solve the inequalities. We want to get rid of that 2. So we're subtracting it. Nope, that's 8 now. 10 minus 2 makes 8. Divide both sides by 5 to get x is greater than 8/5. And then over here, subtract 2 from both sides. We get 5x is less than negative 12. Divide both sides by 5. We get x is less than negative 12/5. So if you want to give it an interval notation, you've got to combine both these facts. X is bigger than 8 over 5. So this fact says 8 over 5 to infinity. It can be anything bigger than 8 over 5. Man, my infinite signs are terrible. Now let's look at this other fact. X can go as far back as negative infinity. And then it stops there at negative 12 over 5. It can't be anything bigger because x is less than negative 12 over 5. And we put a union here. That just means both this and this are the both this and this are potential answers. Let's just quickly graph that solution. Here's a big number line. Here's 0, negative 1, negative 2, negative 3. Now, negative 12/5, that's somewhere right around here. So put an open dot and I'll point it this way because this one says that x is less than or equal to negative 12/5. And we can put a little notation there to say that's exactly negative 12/5. This part says x is greater than 8/5. So there, we've graphed both of those parts on the same number line. These are all the different options. These are all the different options for x.